Hello, my lovelies. It's Miss Lloyd again, here to talk to you about sums of arithmetic and geometric series. So when we're talking about the sum of an arithmetic series, it basically means that we're taking all of the numbers or terms in the series and actually finding the sum of them, so actually adding them together. So the last time we were just expanding or putting them into sigma notation. Here we're actually going to find the sum. So for this first one, for arithmetic, we need the first term, t sub 1, the number of terms are n, and the last term, the t sub n. And just like the arithmetic series, we have a formula for the sum of the geometric series. And so again, we need the first term and the number of terms. But in this case, instead of knowing the last term, we just need to figure out the common ratio. So these are the two formulas that we're going to be using today. And then whenever a hint for when we're in sigma notation, so sigma reminder looks like this. We want to list out the first few terms to determine if it's arithmetic, geometric, or neither, if we can't determine just by looking at the sigma notation what it is. Oftentimes, the T sub n looks like the T sub n formula for arithmetic or geometric, so it can be obvious just by looking. Sometimes it's not as obvious, and so you may want to just list out the first few terms. The first three tends to be my magic number, and look at what it is from there. So finding the pattern after you have those first three terms. So our first example, we're going to find the sum of the first 20 terms of the arithmetic series, and they give us a list of a few numbers and then a dot, dot, dot. So because they said arithmetic, I know I'm going to be using this formula here. So I'm going to copy it and move it down so that I don't have to keep going up to look at it. I mean, I have it memorized by now, but I kind of strongly doubt anyone is writing this down before I move on to the first example. So this is my way of combating that. So here they've told me we're looking at the first 20 terms, so that's my n, my number of terms. They've told me arithmetic, so I've got that formula. I know I'm going to need the first term, so that's going to be 8. That'll be my t sub 1, whatever showed up first. And I don't know what the 20th term is because they just put a dot, dot, dot. So I need to figure out what that 20th term is, and I can figure it out using the T sub n formula. And so since I know we're looking at the 20th term, and I know it's arithmetic, I'm doing that T sub n formula for the arithmetic sequence. So it'll be 8 plus 20 minus 1, and then I have to multiply by the common difference. So here, in order to get from 8 to 5, I would have subtracted 3. And that also works going from 5 to 2. So then I'm multiplying here by negative 3. And when I do this, when I do the 20 minus 1, multiply that 19 by negative 3, add the 8 to it, I end up with negative 49. So my last term, my t sub n, is negative 49, and now I have everything that I need in order to figure this out. So I'm plugging in s sub 20 is equal to, I know 20 is my n, multiplied with the sum of my first term and my last term, and this is going to be all over 2. So when we plug this in, we do want to be careful about the order of operations. So we're doing that 8 technically minus 49 first, and so we end up s sub 20 at the end is going to be negative 410. And this should make sense because only the first 3 terms are going to be positive. Once we subtract 3 again from 2, we end up going into the negative numbers. So that means 17 of our numbers are going to be negative, only 3 of them positive. So we should end up with some kind of negative number when we're adding all of these together. My next example, we're looking at 16 terms. So if I go from 1 to 16, I know my n is going to be 16. Looking at this, because I have the multiplication of 2 times j, I know that this is going to be an arithmetic sequence or an arithmetic series since we're adding everything together. If you can't see that though, you are more than welcome to plug in the 1. I'm going to show how that works just for the first 3 terms. I'm going to kind of speed through it since I already have a video on how to plug this stuff and how to expand from sigma notation. And so here I go from 5 to 3 to 1, and I can see that going from term to term, I'm subtracting by 2. So this is, again, an arithmetic sequence or an arithmetic series. So I'm going to bring down the formula that we were using before. Because it's arithmetic, we're using the same thing. I figured out my n. I know my first term is going to be that 5. So now the only thing left to do is to figure out what my t sub n is. So in this case, my 16th term, since that's the term we're ending on, which is at the top of my sigma here. So then I'm looking for t sub 16. This is going to be equal to my first term 5 plus 16 minus 1. Again, multiplied by my common difference, which I know is negative 2. And so doing all this out, my t sub 16 ends up being negative 25. So this is my last term, so I can plug everything in now that I have all that I need. So my sum of my 16 terms is going to be negative 160. And then we're ready for the next. So here, by looking, I can tell that this is going to be geometric because I have the exponent, my variable as my exponent, so this is going to be geometric. Since I'm doing geometric, I want my geometric formula, so I'm going to copy from up here. Duplicate. Again, I kind of strongly doubt anyone watching this has just straight up written down the formulas. So here we go. Now we don't have to keep going back and forth trying to remember what that was. This means that I need to have my n first off. Because I go from 1 to 5, I know my n is going to be equal to 5. I have 5 terms I'm looking at going from 1 to 5. I need my first term, and so here I'm going to plug in the 1 to the I to figure out my first term is. So t sub 1, whenever I plug in 1, it's just negative 2/3 to the first power, which is just negative 2/3. And then I also need my r, my common ratio. My favorite thing about a geometric formula is that the term that has, or the number that has the exponent is always going to be your r. So my common ratio here is going to be negative 2/3 as well. It's one of my favorite things about it. I don't have to do anything out or create multiple terms in order to figure that out. Now I can plug everything in. So I have s sub 5. I'm going to try to make those look different. My students always tell me my s's look like 5, so you can probably concur. So my first term multiplied with, I've got negative 2/3 to the power of 5. And I know a few of my students are going to be like, oh, Miss, can't you just do plus since you have minus negative? But we have to remember the order of operations here. So at the bottom, I can do the plus out of the minus negative because I don't have an exponent with a negative 2/3. And on the top, I do have an exponent, and order of operations dictates that we have to have the exponents go first before we can do any subtraction. So I would have to have negative 2/3 to the 5th power, do that out before I can do 1 minus that or change any signs. So then plugging this in, if you're plugging into the calculator, please make sure you're careful with your grouping of everything. If I plug it into my calculator, always make sure to have parentheses on the bottom. Whenever we do plug this in or do it out by hand, we should end up with negative 110 over 243. Next here, they're telling me it's arithmetic. So again, I'm going to bring down my arithmetic formula, if it'll let me select it. There it is. And it looks like they've given me the n, they've given me the first term, and they've given me the 10th term, so the last term, which means we have everything we need to just plug in. So I'm going to fast track, and you can follow along that way or try it out yourself. Pause the video and plug it in and compare your answer with mine. So my 10th term, or the sum of my 10 terms, ends up being 1,515. Such a beautiful number in my opinion. I mean, a little redundant, 1515, but I still enjoy it. My next bit, they don't tell me what kind of sequence this is, so I'm going to test it out. So if it was arithmetic, we would be adding by 8 here. And then I would add by 8 in order to get from 11 to 19, and adding by 8 to get from 19 to 27. So this is indeed arithmetic. I'm going to go over and borrow my formula again. Just going to keep passing it along. It's like someone's favorite pair of shoes. So here, my n is going to be the 20. So they want me to find the sum of the 20 terms. I need my first term, which is going to be that 3. And they don't tell me the 20th term, but again, we can figure that out using the t sub n formula. I'm going to do t sub 20. So my 20th term will end up being 155 whenever we do all that out. So now I have everything that I need in order to do out this formula. I'm plugging in 20 for my n. I'm plugging in 3 for my first term, 155 for my last term. This is all going to be over 2. And when we do this out, the sum of those 20 terms ends up being 1,580. Next one. Here, we just have the sequence or the series itself. I know it's a series because there's addition signs. We just have the series itself. I need to figure out what kind of series it is. I always like to test, again, arithmetic first. So going from 50 to 33, I would have subtracted 17. 33 to 16, subtracting 17 as well. So this looks like it's arithmetic. Going to, again, borrow that arithmetic summation and put it over here. I need to know my number of terms, which I can't really tell because of that ... but I do have my 50th, or my first term is 50, and I know my last term, so my t sub n is negative 86. So I can use, again, the t sub n formula to figure out the number of terms. I'm just going to work it a little bit backwards. So instead of t sub n, I'm going to put 86. I know that's the term I'm looking at. And then 50 plus, I don't know what term number it is, so I'm just going to leave an n there. And then I know my common difference is negative 17. So then I can subtract my 50 over. So whenever I do that subtraction, I end up with negative 136 equal to n minus 1 times negative 17. My students typically by now would say, oh, let's distribute in. I would rather get rid of something than put more into the situation. So I'm going to divide by negative 17. And when I do this, I end up with 8 positive. And then I add the 1 over, and my n ends up being 9. Now that I have everything I need, I will plug it into the formula. I've got S sub 9 looking at the first 9 terms. And so the sum of those 9 terms is going to end up being negative 162. Ta-da! Here, they tell me it's geometric, so I'm going to steal my geometric formula from way up here. Bring it down, up, of a right along. There we go. It looks like they've given me everything I need. I have my n, I have my r, and my first term. So I've already plugged this in for you guys before. So I'm going to do speed through this, and you guys can pause if you like. Compare your answers with mine at the end. And so here are some of the first 10 terms is going to be 1,023 over 4. If my students decided to use a decimal, that's fine. I tend to leave them in fraction, but either one is completely fine. It depends on the situation, whatever's easier for you. Most of our calculators have back to fraction buttons though. So here we have our last 3, so we'll look at another sequence with just or another series with just the numbers, and then we'll dive more into the sum, the sigma notations. All right, here I'm going from positive to negative, so I know if I'm doing that, that means I'm multiplying by something. I'm going to grab my geometric formula now. All right, so then I know I'm using 8 for my n. Looking at 8 terms, my first term is going to be that 48. And then I need to figure out my ratio, so how I'm getting from one to the next. And it looks like I would be dividing by -2 in order to get the sign change, which means I'm multiplying by -1/2. And then that works for the -24 to +12 and +12 to the -6. So there's my R, and I have everything I need to plug in. And so my 8th term, or the sum of my 8 terms, ends up being 255 over 8. Again, I'm not going to be upset if there's decimals involved. Fractions are fine. If you're afraid of fractions, you can use the decimals. This next one, again, I know that this is going to be arithmetic because I'm multiplying with my variable. It's not an exponent, it's multiplying, so I know it's going to be arithmetic. I'm going to grab my arithmetic formula, put it off to the side here. That means I'm looking for an n because I go from 1 to 100. I know my n is going to be equal to 100. My first term, I can't really tell just by looking, so I'm going to plug that 1 into the k. So 2 minus the 51 is going to give me -49. I also need my last term, and I can't tell by just looking, so I'm going to have to plug in the 100. So my t sub 100 in this case. Definitely wrong color. So this will end up being 149. Now I have everything I need. I'm just going to plug it in. So the sum of those first 100 terms ends up being a very beautiful 5,000. And then we're ready for our last. Here, because my n, my variable, is my exponent, I know this is going to be geometric. So I'm using this formula up here. I need my n, my number of terms, because I go from 1 to 9. I know my n is going to be 9. There are 9 terms there. My first term, again, I'm going to plug in a 1 to that n, figuring out what my first term is. So simplifying that out, I end up with -960. And I need my common ratio. And remember, the ratio is always going to be whatever has the exponent. So my R is going to be -3 over 2. Now that I have everything that I need, I'm going to plug it in. Simplifying this out or plugging it into your calculator, the sum of the 9 terms should be -15,146.25. So I figured a lot of my students are probably going to be using decimals. This will make them happy. You're welcome. And that is all I have for you today. If you are one of my students, you can find your homework on the LMS. If not, please feel free to like, subscribe, comment any questions that you have. If you know of someone who maybe needs some help in this area, feel free to send them this, share this video with them, especially in the times that we have right now. Sharing is caring. Spread the love.